Hello, welcome. We are in Advanced Algebra 2. We are looking at this second learning target. You will see this time the video has the correct learning target listed. Maybe you noticed last time the video didn't have the correct learning target listed. It's because I cheated and used a video from last year where the learning targets, oh goodness, it doesn't matter. But what does matter is this, common math functions. There are some key graphs and functions I need you to be quite familiar with. These are not terribly complicated ones, well, except for one at the end. Whew, it's a doozy. But the rest of them, not so terrible, but I need you to just kind of get their pictures in your mind and kind of work with them a little bit. Also, I need you to just remember this idea about a vertical line test and make something a function. I'm sure you've seen it before. We'll make sure you get some practice in class. Not terribly exciting, but it's there. So there we go. And now we'll move on to the first kind of function. First of all, a linear function, y equals x. Now, I got to tell you, making a t-chart for y equals x is quite possibly the least exciting thing you could do with your life. You put some x's down, you put some y's down. They are the same things as the x's. So, yeah, I apologize. You just lost 20 seconds of your life. But still, you got to get it down. So you throw some dots down. But before you do that, you need to scale your axes. And since we're only going fives, I just went by ones to make it all work out. Happy, go lucky style. Throw some dots. Doom-ba-doom-ba-doom-ba-doom. Connect the dots because there's no magic reason why just those numbers are the ones that could work. Put some arrows on the end. Boom, linear function. You should be thoroughly unimpressed. I mean, it's a linear, it's y equals x. It's a line, 45 degrees. Slope is 1. The y-intercept is 0. Can't even be bothered to move up or down. Yet. Now, next one. Absolute value. It's possible you've graphed this before. It's also possible you have not. Still not very hard. Go ahead and make yourself a t-chart, x's and y's, and I did the same x's, -5 to 5, but the y's are almost the same, but not quite, because here we're talking about things where when the x was negative, the y made it positive anyway, because of the absolute value. Okay, boom, boom, boom. Throw some axes down, still talking about relatively small numbers, so I went by ones, and then making the dots here, boom, chicka-boom, chicka-boom, boom, boom. And then it's a V shape. Pretty awesome. Still goes forever both ways, but a V shape. Huh. Okay. That's a little bit different than the linear one. Still not terribly exciting. Still not hard, but, it's a thing. Now, I will say this. Both the linear one and this absolute value one, they should look like straight lines, so hopefully you're drawing them with a straight edge. I'm going to need that from you. Again, I can't actually do a perfectly straight line on the iPad because of the way the tool works. Sorry. Okay, moving on. Quadratic function, y equals x squared. You've all graphed a few of these before in your life. Throw down a t-chart. Still went from -5 to 5 on the x's. The y's are the squares, so they're always positive. And they do get kind of big near the 5's. So in terms of scaling, I went by 5's on the y's. You could probably get away with going by like 4's and 3's, but I like to go by 1's, 2's, 5's, and 10's. It's a good, clean way at looking at numbers. Not absolutely mandatory. Certainly not in Advanced Algebra 2, but realistically, it's just a good habit to get into if you're curious. All right, the x's can still go by 1's, because we're still choosing numbers between -5 and 5. Plot the dots, connect it up, it's a UE. I went super fast on that dotting because you should have graphed many parabolas before by now. There's still arrows on the ends because they go forever. All right, moving on. Cubic function. This one you might not have. And I apologize about the page number thing listed on the screen. Couldn't get rid of it. Okay. Now, again, Went ahead and made a t-chart, got x's and y's, boom, boom, boom. Same x's as before. This time the y's kind of go crazy, all the way down to negative 125, and all the way up on the positive side to positive 125. So when you make your scale, you know, the x's can still go by 1s. I went by 10s on the y's. You know, you could do something different if you want. That still won't get me all the way up to 125, but it will get me really most of the information that's going on here. Make the dots, boom, boom, boom. And now it's kind of like a parabola on the right half, but the left half is kind of like an upside down parabola. But the truth is they actually both grow faster. Actually, they grow faster after 1, before 1. This one grows slower, but don't worry about that. They grow faster, or it goes down faster. Okay, next one. Square root function. Now here, x and y's, got a t-chart action. This time I listed all the x's first because something strange is going to happen. When you try to stick the negative x's in, you get a failure. So hopefully you didn't even try too hard, because the negative x's are not in the domain. You can't do a square root of a negative number. You can try really hard. I suppose if you have a good imagination, you can do a square root of a negative number. But that's actually a joke about imaginary numbers, which you're not supposed to know about yet. So it probably wasn't a good joke. All right. However, starting at 0, certainly you can get some values. Now, the problem is the actual values are kind of crummy for most of the numbers, right? It's like 0, 0, good enough. 1 is 1, good enough. 2 is 1.4, 3 is 1.7, 4 is 2, 4, 2, that's nice. 5 is 2.2-ish or something like that. I don't know. It's not, they're not exciting numbers. So I went by 1s on the x's. Oh, and excuse me, I didn't even show it, but on the y's, went by 1s also. I'll go ahead and fix that here. We'll go, oops, wrong color. Went by 1s on the y's, so you look at that. Now it looks like I know what I'm doing. Hey, 1 by 1s on the y's, 1 by 1s on the x's, and zoom. For what it's worth, that is exactly the top half of a sideways parabola. If that sounds like an interesting thing to think about, great. You're welcome. If you're thinking, don't worry about it. Not a big deal for now. All right, next one. Cube root graph. Now this is the cube root x. Again, XY chart, but in this case, I only chose the x's that were going to give me pretty y values. Nice integers for y values. So -8, -1, 0, 1, and 8. Now, again, I could have kept going. -27 and 27 would have been the next ones. -64 and 64 would have been the next ones, but I just wasn't that motivated. Okay, so you go by 1s. I still went by 1s on the y's. There's no, I mean, you could get all excited and go by halves or tenths, probably. Well, not really tenths, but by halves or quarters if you wanted. I just like to go by 1s. Yeah, we'll see. And then, zoom, that's your cube root graph. Wait, nope, I fixed it a little bit. There we go. This is sort of a mirror image of that cube graph from a couple graphs ago. So if you want to go compare with that one and see how they're kind of similar, but this one's sort of sideways, but not exactly sideways, might be interesting. There's something cool there that I'm not going to talk about now, but there's some interesting connection there. All right. Now we're going to have fun. Oh, this last one. This is awesome. Okay. This is y equals x. There's a funny thing that looks like maybe around that x, there's like something like jail bars with like little things going into the ground to stop the x from digging his way out or something like that. It's an actual thing. I didn't make it up. It's called the greatest integer function. But calling something the greatest integer function becomes tiresome for people who know the lingo and feel cool. So we call it the floor function. It's technically the greatest integer function, but every math person knows that means floor. And, okay, this is just so awesome. Not going to do a t-chart because the interesting things happen at the integers, but even more interesting is the nothing that happens between the integers. Okay, so let's bear with me a little bit. Scale it out. Just go by ones, up and down, left and right, everywhere. That part should not be scary. Okay. This is awesome. Okay. Now, let's get started. 0, 0. Everybody likes 0, 0. See the dot at the origin? Great. Now, what's going to happen here is, for every x value, the y value is the biggest integer that is less than or equal to the x value. I'm going to say it again, and if you haven't had enough, you can go back and forth on the video. The y value is the greatest integer that is less than or equal to the x value. So, looking at that x at 0, 0, as I move my way over on the x's toward 1, the y values stay at 0. Except when I get to 1, that's no longer true. So there's an open dot at 1. Now what happens next is super awesome. At 1, the greatest integer that is less than or equal to 1 is 1. So, boom. At 1, you have 1. And then as you work your way to the right of 1, meaning numbers slightly more than 1, but less than 2, the greatest integer that is less than or equal to those numbers is still 1. Until you get at 2, and then it'll change. So we put an open dot at 1. At 2, the greatest integer that is less than or equal to 2 is 2. And that stays true as you move above 2 until you get to 3, in which case the value is 3. And that stays the case until you get to 4, at which case the value is 4. True until you get to 5, at which case the value is 5, etc. Whoa, now that got exciting. Etc., etc. Let me go back just a little bit here. Sorry, folks. All right, now, 5, boom. Now, going back to the left side. For all the numbers between -1 and 0, the greatest integer that is less than or equal to them is -1. Until you get below -1, and then it's -2. Until you get below -2, and then it's -3, etc., etc. Or you can see that the pattern just continues. Now, I got like a dotted arrow thing going on here to show that the pattern continues, not, oh, and then it takes off into a line going straight up, because that's ridiculous. A lot of people look at this and go, hey, that looks like a set of stairs. So in fact, we often call this look of a thing a step function. And I want you to try to understand what a step function looks like. And, you know, if it's a step function, looks like the thing where, like, it's broken everywhere and it kind of follows the same thing and they're all little flat stairs, that's almost something. We can put that together and make it work. Okay, now that we've seen the functions, this time I need you to do worksheet 1, which should be attached to the page of notes, as well before you come back to class, please. It's kind of some baseline work about getting graphs done. It may take you a bit of time, especially if you're making tables, which is totally fine. And you may not have other tools to do it besides that. It's totally fine. But if you would please get worksheet 1 done before we come back to class, we will work on worksheet 2 in class. It's going to be a great time. Thanks for watching, and as always, let me know if you have any questions.